Today's lecture is on test adequacy criteria and structural testing, or as we also might call it, implementation-based testing, in contrast to the function or specification-based testing that we talked about last time. And well, we will try to answer this question, sort of, at least based on the implementation. So how do we know what we tested or did not test? So that will be the focus of the lecture today. And I will talk about, of course, the fundamentals of implementation or structural implementation-based or structural testing. I will also talk about the notions of adequacy criteria and coverage. And I will give two examples, or maybe you could say the main examples of implementation or structural-based testing. Graph-based adequacy criteria and logic-based adequacy criteria. And then I will also go into a couple of important considerations for structural testing. So that's what I will talk about today. And as always, if you have any questions or comments, just please raise your hand and we will discuss during the lecture. Okay? So fundamentals of structural testing. You remember these circles. Again, let me just talk about where we are on the map here. We talked about the desired software behavior. We talked about the specified software behavior and the implemented software behavior. We put these on top of each other and we said that if we focus on functional specification-based test design, we will, our test cases or our resulting test cases will end up mostly in the specified software behavior, right? Because we're using the specification as the base of the test design. With the structural testing, we're focusing on starting from the implementation. We're focusing, and our resulting test cases will target the actually implemented software behavior. So my point here is that these are complementary. Another way to look at it, saying perhaps the same thing, is that you remember this sort of overview picture of test design techniques. Previously we talked about specification-based testing, then the specifications are the software artifact that you use for your test design technique. Now we're looking at the code or the implementation. So to sum it up a bit, well, functional testing is about covering the specification in different ways, whereas structural testing is about covering the implementation. Okay? I think I said the same thing 3 times now, so I guess you'll remember it. But one thing that is important to remember when we talk about test design, and it relates to a discussion that we had in the end of last lecture, so where does the expected output come from? And in functional testing, if you look at the specifications, they typically look sort of like, in this case, or if this happens, the software is supposed to do this. Here you have an idea of what would be the input and what would be the expected output. That information is sort of all contained in the specification of the software and the test. Whereas if you start from the implementation and try to derive test cases, you can reason about which inputs would be reasonable to test. We can talk about test specifications based on how the input or the implementation looks like. But in order to know anything about how the software should behave, you still have to go back to the expected behavior or the specification of the software, right? Because the implementation only tells you or gives you information on how the system or the software actually behaves, right? So you need the specification here to know the expected output. To sort of create complete test cases, you can get some idea of the input here, but the expected output, you need specification. So That being said, specific or implementation-based test design. My first question to you, how do you know how well you cover an implementation? This is like an example piece of code that I will use throughout this lecture as an example. It's part of Edsker-Dijkstra's algorithm for finding the shortest path through a graph. It doesn't really matter what it does, but just given that you have this piece of code to test, how would you know that you covered it? Any ideas? If you just look at the sort of the implementation, what's the code here? When do we know when we can stop testing? Well, one thing that you could do at least is to say that I will not stop testing until I have tested all parts of this software. Right? Seems fairly reasonable, right? That you want to test all parts of the software that you've implemented. Otherwise, you will ship or integrate or sort of launch untested code. Right? So you want to test everything here. Right? In some way. You don't want to have anything that is not being tested. You don't want to ship software where you have lines of code that are not have not been tested at all. So, let's start with one very simple or sort of basic notion of coverage. Statement coverage. How many of you heard of statement coverage? Okay, so at least half of you heard of statement coverage. So what does statement coverage tell us? Okay, very good. Then there's a point that you're being here. That's very good. Because if you would already know this, that wouldn't be a point in you being here. So this is a statement. It's sort of, it could be translated to a line of code. It's not really that simple, but sort of. So this is a statement. This is the assignment of the mini variable to the value of -1. Okay, that's a statement. And statement coverage, where you say that I will say that my code is fully tested or adequate with respect to statement coverage if I have exercised or executed all my statements in the code during testing. Right? Quite simple. And I would say that this is perhaps the most commonly used form of code coverage. It's the sort of most basic form of code coverage. So you're saying that I want to test all my statements, or as many as possible of my statements in my code. And that's sort of the way I know how well I cover my implementation. And let's just, if we talk about some terminology here, statement coverage, it's an adequacy criterion, meaning that it tells us how adequately our test cases or test suite covers the implementation. Okay, so that's the terminology used. Also, statement or adequacy criteria are sort of built up of coverage items. You're saying that I define my coverage items and then I say I want to cover all my coverage items. And in statement coverage, statements are the coverage items. Okay, as we shall see, there are many other types of adequacy criteria that you can use that have different coverage items. If you would compare this to what we said in the lecture on functional testing, the coverage items can be seen as test specifications. Okay, it tells you what your testing needs to satisfy or fulfill. Okay. So again, as I said, adequacy criteria are formal criteria used for stating how well test suites exercise the implementation. And one way, and I'll get back to this, to think about adequacy criteria is more actually as inadequacy criteria. Because it's in a sense more important to know what hasn't been covered than what has been covered. Right? So if all of your code has been covered, that doesn't tell you as much as knowing that perhaps 30% of your code hasn't been covered, and which 30% of your code hasn't been covered. And as I said, an adequacy criteria applied to an implementation will result in a set of coverage items that should be exercised during testing. Okay, so if you would happen to read a book or something like this, then you would know that, or you find different names for this. Test items, test obligations, test requirements, test specifications. So there's sort of a jungle here in terminology. Okay, so this looks a bit formal, but it's really not. It's quite easy actually. So how do you measure coverage, or how do you sort of calculate coverage? Well, actually you just take the coverage of a test case given a certain adequacy criteria or a test suite, and the system under test is the number of coverage items that you have tested divided by the existing number of testing or coverage items. So this is always a number between 0 and 1, often given as a percentage. You can say I've tested 80% of my statements. So if we go back to the example that we have here, this piece of code has 14 statements, right? So it's a very simple, small piece of code. So these 14 statements, if we just assume that we have one test case with an input and an expected output, and in terms of, as I said, in terms of statement coverage, it's only the input that matters. The state or this adequacy criterion doesn't put any constraints or sort of any on how the expected output is treated or the actual output is treated and compared. So it only tells you what has been covered or executed. So let's say that you have an input that executes 10 of these statements, the 14 statements. So what coverage do you have? Well, you simply divide the number of executed statements by the number of actual statements in the code. 10 divided by 14, roughly 71% of coverage you have. And you have, well, if you have to go back here to see, but you have a couple of statements here that are not covered.